Good morning. I'm Allison Meyer. Thank you for joining us for this month's MEYERTech webinar. We will be continuing this webinar series every other month to share insights into the many ways Meyer is using tech to troubleshoot, solve problems, and develop solutions in our industry. To start, I'd like to take a minute to tell you a little bit about Meyer. Meyer is dedicated to manufacturing the highest quality well testing equipment and control systems, ranging from BOP drilling and accumulator units to wellhead grease manifolds and hydrostatic pressure testing units. This month's featured speakers are Blake and Joe from IOT-eq, the Internet of Things. IOT-eq specializes in data integration, and their family of products were built from the ground up to talk to your control systems and make moving that information around easier than ever before. Each of IOT-eq's devices run a single, easy-to-use platform designed with just one purpose: to move data from the ground or lower to the cloud or higher while providing visibility, control, and security every step of the way. Please feel free to send questions to Blake and Joe during the presentation using the chat function here, and we will do a short question and answer session after Blake and Joe present. We will be very respectful of your time.
Good morning. I'm Blake Burnett. I'm the founder of IOT-eq, and this is Joe Guerrera. Joe is our manager of engineering at IOT-eq, and so we're here to talk to you today about what IOT-eq does. And the bottom line is, at IOT-eq, we use cutting-edge internet technology to save companies money. We drive cost savings. So, Joe.
Yeah, basically from the outside looking in, IOT-eq might be seen as a controls company, but we're much more than that. We're kind of a controls company for the internet age. All of our products are focused on bringing visibility to our customers of the processes and equipment that they may have in the field. And all this is to give them visibility so they can manage and efficiently optimize their processes and equipment.
So the IoT and IOT-eq stands for the Internet of Things, and the Internet of Things is basically the connecting of different devices over the internet. So they're, like the Amazon Alexa or things when you control the lights from your iPhone, that's the Internet of Things. But then there's a term, the Industrial Internet of Things, which means kind of the same thing, but out in the field for heavy equipment.
So in this slide, you'll see just a few of the applications that we currently have our devices on, including drilling rigs, artificial lifts, and a frac site. One of our customers works in artificial lifts. They hired us to implement a pump jack performance monitoring system. Using our software and our devices, they will be able to monitor potentially hundreds of units out in the field across all the different shale platforms, shale formations in the country. This will give them the visibility to see if what's going on with production, if there's anything wrong with their units, they can send someone out there to fix them. Down in the bottom, you'll see a frac site. Over the last 3 years, with the help of our customers, we've been able to integrate our systems and products into virtually every component, every part of a frac job, from the sand delivery all the way to the wellhead. This includes sand delivery automation system, cam silo controls interface, control systems for blenders, frac pumps, ChemAds, monitoring software for data vans, and a revolutionary pump health monitoring system, which we're very excited about, all the way to the frac stack automation systems.
Yeah, so a lot of companies that are out on frac jobs don't realize that our software is actually running in most of the frac vans out there in some form or fashion, because the third-party contractors use our software and our wireless gateways. So they'll have tablets inside the van that connect to our gateways and show different things going on the job site, like how much sand there is or how much chemicals there are. Also, we are in drilling. We have one customer in drilling, and that's Meyer. And so Meyer puts our gateways on their closing units so that they take the information from the PLC and serve it up as web pages for their customers, and they can access it remotely over the internet or at the job site. And Meyer did some really interesting stuff with the gateways, because we'll talk some more about how you can create your own web pages in the gateways, but they actually created some really beautiful reports within the gateways. So whenever I present about the Internet of Things, I always start out with this slide, because it shows, you know, in my past history, in a previous life, I worked for a very large company, and we had thousands of trucks. And back in the 80s, we started putting sensors on the trucks, electronic sensors. And then in 2000, we got satellite connectivity from the frac sites, and we started sending the data real time over the satellite. And then we installed a server, and that took a long time. And I have a little note there, it took us 2 years. And the reason I put that note on there is so that people know that, you know, with cloud databases now and cloud servers, you can stand up a server in just a matter of minutes. And so whenever there's discussions about whether to use cloud or in-house servers, I always like to point that out, how you can scale so quickly using cloud. But then we developed custom dashboards around 2010, where you could see what was going on with all the 2,000 trucks out there. And one of the things we learned is we thought once we developed those dashboards that the project would be finished, but really the project just started. Because once we developed the dashboard and we turned it on, we immediately got 2,000 overheat alarms from the trucks every day. And so we had to go out and research that. And what it turned out was that they weren't washing the radiators. And so we, you know, started policing washing the radiators, watching the dashboard. We could tell who wasn't washing their radiators, and we were able to drive significant savings in transmission repairs. At that time, we were spending $16 million a year in transmission repairs. So then after I left that company and I started IOT-eq, a friend of mine from that company contacted me, and he said, you know, we just brought the insurance company through and showed them the war room and showed them what you'd set up with IoT. And the insurance company gave us some huge insurance cost savings. So there's an added cost savings there that most people don't realize, that when you set up a war room and you start monitoring your assets remotely, you can actually generate some insurance savings off of it.
So one of our devices is what we call the DI series. It's some equipment portals, as we like to call them, which provide you a digital twin in a box. So gateways are everywhere, anyone can get them. They're not new, but what makes our gateway special, different from a traditional gateway, is we like to call it a device portal. It allows you to have visibility to the device that's in the field. It opens the door to greater visibility and greater management. If you can't see it, you can't manage it, right? So they're built on a protocol. They're built around, you know, being easy to configure, multi-protocol gateways, so they can talk to some of the most popular programming protocols in the industry. They're simple, reliable remote monitoring management, and they have a internal scripting for small processes, and they're extremely configurable. There's a web-based drag and drop HMI that you can create. You can import pictures, whatever you like, and it makes it very simple for the user or us to configure however they would like. And all this is available via a local area Wi-Fi network that comes straight from the device, or via cellular connectivity, where a user could pull that up on their laptop or smartphone from anywhere in the world.
These were actually the first gateways to have 5G technology. And we worked with T-Mobile for their 600 megahertz 5G technology, which gives longer distance. It gets you from 15 miles from the tower to, they advertised 25. We tested 35 miles from the tower, which gives you greater penetration into the oil field. And then if you look at those two pictures up there, the one on the left was developed by a company called Mesquite, and the one on the right was by Meyer. And in both those cases, they designed their own screens, and Meyer went into the drag and drop interface that's built into the gateway. You can just connect to the gateway with your phone, and you can go in and design these web pages, and you can drag and drop tags from your PLC onto your pictures or onto your background screen, and then and then save that in the gateway. And then if anybody goes up and scans a QR code and connects to the gateway, they can see those things. Of course, you can put password protection and things like that. But the one on the left, actually, Mesquite Technologies, they designed that screen, and they had exactly what they wanted, and they sent it to me, and I just dragged that screen and dropped it into the gateway with the drag and drop interface, and then put the tags on there that they wanted to see from the sensors that they were getting from a company called Stellar Technologies. And then they were, from that point, if anybody goes up to that gateway or connects to that gateway over the internet, if they have the security codes, they can go in and see all those parameters live. So this slide's something we call local e-forms, and what it is, there was a company out in Odessa that pumps water, and they have to file a report with how much water they pump. And so they were asking for a solution for that. And so I just took a form. This isn't the actual form they use. I just grabbed this off the Railroad Commission's website. But you can drag and drop a form onto the background with the drag and drop web server interface into the gateway. And then you can take the information from your flow meters you're connected to or whatever and put them on the form. And then the form's automatically filled out for you. Anytime you scan the QR code, that form pops up with the values already on it, and then you can PDF that form and send it off to whoever you need to send it to.
Another thing we do is custom IoT devices. A lot of companies now, or some of our customers, are going to like a charge by the hour, power by the hour model. So with our devices, we can monitor those devices in the field and remotely connect to them to allow our customers to know how long those units are running, and also give them performance data or maintenance data. Some of the different companies, some of the different technologies that we've used is Bluetooth Low Energy. We do custom circuit boards here. LoRaWAN. We do podding for IP ratings. We use long life batteries, GPS, signal splitters, which is analog signal splitters, or frequency signal splitters, which could be for RPM sensors and such, or pressure transducers. One of our products, just one of our solutions, actually incorporates signal splitters, custom circuit boards, Wi-Fi, GPS, potted in a IP69 rated enclosure, 3D printed enclosure, and that's just one of our products.
Yeah, so some customers, they want to buy in the very large quantities, hundreds or thousands. So in those applications, it makes sense for us to spin up a custom application like this, custom circuit board.
One of our flagship products is our Dura1 Edge controller. It's a edge controller and industrial controller and edge computer in one package. It's fully IP66 rated. It's extremely configurable. You'll see here, all those different cards are used for different inputs and outputs. We have everything from analog inputs, analog outputs, digital inputs for frequencies, digital outputs for controlling relays or solenoids. And we also support CAN bus J1939 protocol. So with those expansion cards being interchangeable, we can configure a Dura1 to control almost any type of system that the customer needs. It's completely designed in-house. It's got the ratings, the temperature, high temperature ratings, operating temperatures, and high IP ratings as well.
And one of the things we like to say about this is you can make machines that think, because it does have a similar drag and drop interface where you can just drag and drop items onto the screen, and then when you can operate your equipment from a tablet. We have one customer that's operating a new blender, frac blender, from a tablet using this device. So it's real easy to configure and set up, but at the same time, you can put Python code into things like a button or something like that, and then from that you can actually, what we like to say, make machines that think. So this slide is about the beauty of the Python language and having it running on your controller. So I mean, everybody's familiar with PLCs. Well, our controllers are kind of like PLCs, but they're more rugged, where they like the engine control module in your car. And that's because in the oil field, things have to be really tough. They have to be bulletproof. They have to be waterproof. They have to have an extremely high temperature range. And so not always is factory automation stuff the right solution for equipment in the oil field. But then on top of that, you know, with us combining the edge computer, that an edge computer is when you stick a piece of a computer on a piece of equipment, that's called doing your computing on the edge. And what you're doing is you're analyzing the data and for certain parameters and things like that, and just sending that information to the cloud. That's called edge computing. Well, we've taken that a step further by combining the edge computer with the controller and being able to run the Python language. We can actually make machines that can see and can think. So TensorFlow is a library for Python that gives you artificial intelligence capabilities really easily. And then there's PySpeech, which allows your machine to talk, or you can talk to the machine, just like using Alexa or Siri. And then, so the machine can tell you, you know, what the pressure is at the wellhead or something like that. But then also there's the OpenCV and PyImage search. Combining those two Python libraries, you can really make something that sees. So we're going to do a demonstration here, just real quick, this little video. We're measuring the height of that ping pong ball. So imagine that you're doing this for a PLC that is or not a PLC, but in place of a PLC, you're putting our edge controller, and you want to measure the sand level in a sand hopper with a camera. So the camera, our controller can actually, by using those libraries, see what the level is in the hopper and read the level from a camera.
And one of the problems that faces our industry as a controllers company is access to real life testing environments. For example, frac pumps. There's a lot of costs associated with setting up a job or setting up a pump in a lab to test for failures and whatnot. One innovative method that we've done to tackle that challenge is we recorded one set of real life data, brought that to our office, and we're able to replicate that using electromagnetic simulation. This allows us to build software, build components that monitor or detect these faults, and we're able to run hours and hours of tests without accruing the cost that comes with those real life simulations and real life tests.
And so one of the applications, of course, here that's really this has been really helpful for is frac pumps, but this has applications in any type of real world vibration application.
Right.
So another thing about the Internet of Things is when you're trying to put machine learning control systems out in the field, they need to be monitored kind of closely, because machine learning, you know, it kind of has to be coached and developed over time, and you need that feedback of how it's doing when it's out in the field. So by using the Internet of Things and connecting to the equipment remotely, you can monitor the machine learning applications. So Joe, why don't you explain this?
So this video is part of our automated sand delivery system. This is testing that we were doing where we take the input from that level probe that you see in the hopper, and our system is designed such that you can choose the sand that you want to deliver and the set point that you want it, and the system will automatically adjust the rate at which that sand comes in to keep that level. That is huge for companies where traditionally they've had a guy there that does this, and he may not be paying attention, or he may fall asleep, or whatever that is the case may be. And you end up with either a dry hopper, which ruins your frac stage, or you end up with a ton of sand on the ground, which it just costs and wasted money. So all of our solutions are geared towards increasing efficiency, visibility, reliability, and all that generates more cost savings for our customers.
And where machine learning fits into that is our customers, their customers, each one has a different size hopper. So by having machine learning kind of learn the size of the hopper, that the size of the hopper affects the gain of the control system. So using normal gain, normal control algorithms doesn't really work from hopper to hopper. So by using machine learning, we can, the system after a while can start to get a feel and say, hey, it's a small hopper, it's a big hopper. So this slide is about point-to-point versus cloud Internet of Things. And this is really important if you're looking at getting into the Internet of Things. There's a line, a horizontal line there across dividing the two halves of this slide. And you'll see that on the top half is kind of the traditional model of what people think of as the Internet of Things, where you have a whole bunch of pieces of equipment and they're sending data to a cloud database and it's being recorded. And then from there, it's either being accessed via reports and things like that, or it's feeding into a neural network, which learns about the information. And then from that, you can gain actionable insights. Well, that business model is okay for a really large company, like say Exxon or something. But for a smaller company, that's pretty heavy. And it takes a long time to get there as well. Now, regardless of the size of the company, the traditional model is expensive and your time to market's quite a bit longer. On the bottom, we have what we call point-to-point IoT. And point-to-point IoT is nice because you can get up and running this afternoon. So you take one of our gateways there on the bottom left, and you connect to it over the internet through a website we have called Tech Connect. And then from there, from your phone or from your computer, you can actually even design the web pages and store them back to the gateway, or you can design them ahead of time and have them in the gateway. But then you can call up those web pages and see the parameters from the equipment on your phone or on your computer in real time. And once again, so the advantage to the point-to-point is that you can be up and running in a few hours as opposed to a few months. And this slide is just about mapping. I put this in here just because one lesson we learned on mapping software is that some of the mapping applications, the windows, you can only have one pop-up window open at a time. And we use Google Maps because you can open up multiple windows and all at the same time. So if you want to have multiple pieces of equipment in your map view, you can see them all. I started out using a mapping software called Leaf, and I kind of ran into an obstacle there where I could only look at one piece of equipment at a time.
So you'll see one of our products being tested for IP protection, and also we tested it for operating temperature. So here at IOT-eq, we pride ourselves on making our stuff oil field proof. That means it has to withstand the environment that they'll be subjected to in the oil field, which is extreme temperatures, rain, weather, all kinds of different environments. So here at IOT-eq, all of our stuff is designed with a minimum IP rating of IP66, which is dust tight, watertight. In this example, this is IP69, which means it's fully submersible. That unit actually is on at that time. It was tested overnight, ran overnight in a bucket of water. So, I mean, that you can't get much better than that. We have stories of some of our equipment that went through in a generator fire for however many hours it was in. We got it back to our office. We swapped out some of the wires and some of the cables that melted, and it booted right up and continued to work. So it's oil field tough. And that means as far as high operating temperatures, talking minus 40 to 175 degrees Fahrenheit or 80 C, which is an industrial standard for our components.
Okay, so are there any questions?
Blake and Joe, so a couple questions we've gotten in are, what are the possible applications and industries for your products?
Well, although most of our customers are in the oil field, not all of them are. We actually have one customer that's in aviation, but really our products can be used across any industry. And I mean, from putting them on you could put them on pool pumps to monitor pool pumps remotely, and you could put them on HVAC is one huge application where we could monitor HVAC equipment. But we even played around with actually putting menus for restaurants inside the gateway. So when you scan the QR code via Wi-Fi, you hit the gateway instead of going through the internet or them having to have a web page, on a website for the menu. So these applications or there's applications on the IoT gateway side for everything, but then also on those controllers where you can build machines that think with our controllers that can see. If you wanted to build a machine that bricked houses, you could actually do that with our controllers with the Python language. And a lot of times I'll see robots wandering around the floor of Walmart taking inventory or mopping the floor and stuff, and I'll snap a picture of that and put it on Twitter and say, hey, if you buy our Edge controllers, making one of these is really, really easy. So because having the Python language really simplifies robotics and making a machine that thinks.
Right, and with our DI series gateways, being that they're multi-protocol and they support all of the most popular programming languages, it's easy. They're instrumental in us retrofitting the existing equipment. So if you have a piece of equipment that uses a PLC, an Allen Bradley PLC, for example, that's been in operation for 15 years, that doesn't necessarily mean that we can install our equipment on it. We're able to automate processes or just give the customers higher visibility into what's going on in the field with their devices.
One other question is, what percentage of your customers design their own web pages put inside the gateway, and how many have you designed for customers?
So 2 of our customers have designed their own web pages, one of them being Meyer, and another one was California Resources. And then for the rest of our customers, just because they didn't really have time to do it, they just had us create the web pages and save them inside the gateways for them.
And how many have we done? I mean, each gateway we can have there's not a limit to the number of pages that can get there. I mean, maybe there is just based on traffic and speed and processing power, but we haven't found it yet. There's gateways that have 20 different pages in there, 20 different screens. So, I mean, it's almost limitless, tons of possibilities.
In closing, thank you again for spending this time with us today. If you have any other questions about IOT-eq or Meyer, please feel free to call or email me anytime. Our number is 877-44-MEYER, or you can send me an email at ameyer@meyernow.com. And we'd love for you to join us at our next webinar on the best greasing practices in the industry. Thank you and enjoy your day.